everyone, welcome back to my channel. So today in today's video we are going to solve the LeetCode problem number 2654, which is minimum number of operations to make all array elements equals to 1. So this problem is all about using the GCD or greatest common divisor to gradually reduce numbers until the entire array becomes filled with 1. It's a very logical and math based question. So let us go step by step. So we are given a zero index array num, which is consisting of the positive integers, and in one operation we can choose such we can choose an index I in such a way that 0 is greater than less than equals to I, which is less than n minus 1, and it can be either replaced by I, which is num I, or num I plus 1 with the GCD of those two numbers, which is here we are given. So now what we have to return our goal is to make every element in the array equals to 1 using as few operation as possible. If it is not possible, impossible, if it is impossible or not possible for us to return, then we have to return minus 1. So let us take the example that is given to us and understand how this works. Suppose we are given an array num 2634. We want to convert everything into 1. So we start by looking at pairs of numbers and apply the greatest common divisor operation. So between this 3, just a second, between this 3 and 4, the GCD is 1. So if we replace 3 with 1, the array becomes 2, 6, 1, 4. Now that we have 1 in the array, things become much easier because the GCD of 1 with any number is always 1. So next we will we use that 1 to start spreading throughout the array, taking the pair. Now we will take the pair 6 and 1, because here it becomes 1, so it will 6 and 1 we are going to take. So after taking the GCD of it, we get another one, that is 2 1 1 4 here. So after that, when we get the 2 1 1 4, what we are going to do is we are going to make the first element, which is of 2 and 1, as 1. So we are going to take the next pair, which is 2 1, and we are going to make it again 1. So its GCD will be finally 1. So we will be remaining with 1 and 1 1 1 4. So we will take 1 4 as the next number, and the GCD for that will be 1 as well. So after total 4 operations, we are going to get all the elements in an array as 1. So the output will be 4. Now coming to 2, 10, 6, 14, which is the next example, which is an array. So here see, if we calculate the GCD of any pair, it will never become 1. For example, GCD of 2 and 10 if we are taking, so it is going to be like 2, and if we are taking 10 and then we are taking 6 for example, so again it is going to be 2, and even if we take 6 and 14, it's going to be 2. Since we can never produce a single one anywhere in this array, it is impossible. So as we were told that as in the question we were told that if it is impossible, then we have to written minus 1. So here we have written minus 1. Now I am going through the code, I will write up the code and make you guys explain about it. Okay, so let us dive into the code. I'll quickly write the code and make you guys understand after that. So here already we are given a class solution and public int minimum operation, which is min operation, and we are given an int string, which is num, called as nums. So here array length equals to nums dot length. After that, int once count equals to 0. For int nums, if num equals to 1, then once count will be incremented. After that, if one's count is greater than 0, then what we are getting or returning is array length minus one's count. Okay, here we finished that. After that we are going to write int minimum sub array. Length equals to array length plus 1. So for int I equals to 0, I is less than array length and it is I plus plus. After that, opening a curly braces, we are going to write int current GCD is equals to 0. For int j equals to I, j is less than array length, now j plus plus. Okay. After that, current GCD becomes GCD of current GCD comma nums j. After that, if current GCD is equals to 1, then mean sub array length is equals to math function we are writing, which is math.mean, which is mean sub array length is equals to mean sub array length comma j minus 1 plus 1. So this is what we are writing and we are breaking the statement. After that, if mean sub array length is greater than array length, then what we will be returning? Minus 1. Now return array length minus 1 plus mean sub array length minus 1. Now private int GCD int a comma int b return b equals to 0, a is equals to GCD b comma a percent b. So here's the code that I have written. Let us first run it and see if there is any error, or if both. Okay, there is a one compiler error at line number 10, which is okay, the count spelling should be COUNT, small o. Let's hope for the best that there is no such more error and the code is perfectly running fine, guys. And here we are submitting it. Now I'm going to explain you the code. So here, as we understanding this code, the first thing the solution does is it count how many numbers, or like how many elements are already equals to 1 here, or it already counts that what's the count is equals to already 1. So if there are any ones in the array, we are in good condition, because those can easily be turned used to turn their neighboring into 1. In that case, we only need to perform n minus number of 1 count right here, from here, in that case. Okay, now as we, since each like non 1 elements can be covered to 1 using the GCD operation if it has its neighbor as 1. Okay, so if there are no ones in the array, okay, now coming to the another one, that if there is no ones in the uh, array, so then we will create the first one. For that we look for the smallest possible GCD, and after that what we do is, like whose subarray whose is 1. This means that we will check every subarray from index I to j, as we have did here. I and j, we are checking it constantly. We will compute their running GCD, and as soon as it becomes 1 we will stop, because that subarray can produce like possibly it can produce soon, right, the ones that we are looking for. So all amongst all the subarrays, we take the ones with the smallest length, which is the minimum subarray. That is what we are going to take, so that we want to maximize the number, like minimize, we don't want to maximize the number of operations, but minimize the number of operations to generate a very first of the array. Now if we are going towards this part here, what we are showing, or what we have written is, if there is no subarray ever produced a GCD of 1, that means it's completely impossible to get even a single one in the array. So this function immediately returns -1, as it was already given to us in the question. There is something wrong as well here for a required output. I'll check that again, what's this issue. But let me complete with this code, because the possible case is going right. Okay, so after that what happens is here. So now as we written like this is what I was talking about, like -1. After that, otherwise only we will have to found the minimum number of the subarray's length that can produce a 1. So we can calculate the total number of operations. So the first subarray length -1 will like this one, so subarray -1 uh, that is going to like create the first one, and then we will be needing n minus 1. Okay, and more operation to spread that one across the entire array. Adding those together gives us a final answer. So finally there is a helper function that computes the GCD of two number using the Euclidean algorithm, a simple recursive formula where the GCD of a and b is equal to the GCD of b, and a percent b comma until b becomes the 0, right? So overall the solution, first check the existing ones, then search for the shortest subarray that can create a 1, and finally calculate how many steps are needed to make it, like make all numbers equal to 1. That it's a very elegant mixture of maths logic, array traversals and optimization. Okay, so while I was like running the code, our cases were already coming right. I'll show you, both of the cases were definitely going right, but while submitting now I can see that there is some kind of error if I'm getting this test case run, right? So let me see if I have did anything wrong in my code, because previously I have run the same code and I got it right. So we have written int array length equals to nums dot length, int ones count equals to 0, which is the start, and for int num, which is nums, if num equals to 1, one counts get credited or incremented. So till here we are right. So if one's count is greater than 0, then the array will be returning to us array length minus one's count. After that, if like int means of array length is equals to array length plus 1, then for the integer I equals to 0, I is less than array length comma I plus plus. So in that we are getting current GCD equals to 0. So for int j equals to I, j is also smaller than array length, where j plus plus. So it is going to give us the current GCD which is GCD, which is current GCD comma nums j. So if current GCD is equals to 1, then we will see we will get the minimum subarray length, which is math dot min, which is min subarray length comma j minus 1. It should not be 1, it should be I. Here what we have made the mistake, plus 1. So we'll break it. After that, let's continue it further. We have did if minimum subarray of the length is greater than array length. So here as we go, we will be returning minus 1. So return array length minus 1 plus mean array length minus 1. So last is our helper function, which is private in GCD. Int a comma int b returns b equals to 0 question mark. A is to GCD b comma a person b. So now let us see, after running our test cases, eventually our test cases are going to be true. Let's see if our other test cases running or not now. So yes, here we go. So that was the only one issue that was coming, which was here we have to write j minus I, not j minus 1. So thank you guys, hope you like it. Do let me know if you have any doubts in the comment section. I'll make sure I'll comment down, or in the next video I'll make sure I clear it out. Thank you.